functional groups are is up until now we've talked about organic molecules containing carbon and hydrogen, and they will always contain. Yes, sorry, we're on page 23.
I don't even remember doing isomers, but I did the sheet. It wasn't hard.
It's not that different from what we've done before, so it's kind of like a review. Okay, so functional groups. We've talked about organic molecules containing carbon and hydrogen. These will still contain carbon and hydrogen, but now we're going to look at things that also contain some other elements, like oxygen especially, and nitrogen, and sometimes the halogens. So if you look at this first page, I've got two examples of like real world molecules. So the first one that says estriol, that's estrogen. So that's what estrogen looks like. That's the hormone that gives female characteristics. That is the organic molecule that makes up what estrogen is. So if we look at it, we've got some rings. So those contain carbon and hydrogen. What else do you guys notice?
Methyl.
There's a methyl group, so a CH3 group. Yep.
And then,
Do we have some things there that aren't carbon and hydrogen? Yeah, we've got some O, so we've got some oxygen. We've got this ring that has some double bonds in it. That's what those lines mean. So we're going to learn to recognize what that oxygen tells us and what that ring is with double bonds. The one beside it is testosterone. So some similarities. It looks like it's got a lot of similar ring shapes, but different groups or functional groups attached to it, which changes the properties. Okay. So next couple pages notes, I'm just going to kind of walk you through. This is just a very small version of this. So this is a reference sheet that you can use throughout this unit. Aromatics, I just drew those on the bottom, so you have them. So when you see a ring, a six-sided ring that has double bonds, that's called an aromatic. So that's a group that we're going to learn to recognize. Then it's showing us some different versions of that double bonded ring, making a Lord of the Rings joke. That's one ring to rule them all. Okay, and now we're going to get into some practice. So I'm going to just redraw these groups, and then I'll show you how we can start to practice to use the yellow sheet to recognize it. So got that.
I don't think so they make the car go fast and
That guy, and then the last guy over here. So we're on slide 50, so page 25. And I'm just redrawing what you guys have, so we can go through these. So. Okay. Yeah, just goes up at the front there, Matthew.
I just have one question. For positional isomers, that would be kind of like how thalidomide had
the mirror
this
image.
way and then the mirror image. So it would just be like a reverse of the first one. Okay.
Okay, so if we look at this very first one, what we're going to do is we're going to circle anything that's not carbon and hydrogen, and then we're going to go to our yellow sheet to figure out what that is. So we've got an O. Now that O, before we go anywhere, let's take a look at what's happening with that O. So that O is single bonded to a carbon on this side, single bonded to what would be at this point? A carbon as well. Okay, so we're looking for an O that's single bonded to two carbons. So we go to our yellow sheet.
dimethyl ether.
Okay, so yes, you're in the right spot. We're not really going to use this information. We're really just going to use this. We're just going to call it
An ether.
an ether. So how did you know it was an ether? Let's take a look. This example here shows O, single bonded to carbon, single bonded to carbon. So it is ether.
Would this also be ether?
Yeah. So you went down on your page, so it's this one here, because at the point, each point is a carbon, so an oxygen sandwich between two carbons, also ether.
This would this be an amine?
Okay, so let's say amine would have an N. We don't have any N's there. We have O. So another way to write this, because sometimes these aren't drawn out enough, we could also think of this as O to our CH third group and to an H. It's an O to a C and an H.
So an alcohol.
So it's an alcohol. Yeah. Now this last one, we've got two O's. So what we want to know is that one thing or is it two things? So let's take a look. Where do we have double bonded O's? Kind of towards the bottom, okay? So it could be, yeah.
You said two O's? Yeah.
So we've got two O's.
Would it be carboxyl?
Okay, so in order for it to be a carboxylic acid, you're right. So we've got double bonded O, single bonded O, but this goes to a carbon and this goes to a carbon, not an H. So it's not quite, it's the one below it, yes. The ester. So we'd circle this whole piece and call it an ester.
Weird names.
I know, there's some strange ones out there. Okay. You guys start to take a look. I'll get them drawn up here.
Oh, yeah.
Any comments or anything?
Or yeah, we watched the fight.
This is pretty.
The UFC.
No, it is. It's very, very rare.
Okay, I think I've got them. What are you guys thinking so far?
There you go.
Yeah, haloalkane. So we've got a chlorine. So if we look on our yellow sheet, here for the haloalkanes, it has an X in the middle. Well, that X can be any one of our halogens. So fluorine, chlorine, bromine, iodine, any one of those. And then we have what's called the haloalkane. Okay, next one, we've got a double bonded oxygen. So we gotta take a look. What is that double bonded oxygen attached to?
Aldehyde.
Yeah, carbon, yes. That has a hydrogen and another carbon, so aldehyde. How about the next one?
Wouldn't it be the same?
It is the same, yeah. That carbon is double bonded and then hydrogen.
And the other one would be the same.
Okay, let's double check.
Carboxylic acid.
Okay, so if it was an aldehyde, let's do Blue Jays first. So this carbon is bonded, so the carbon that has the O is bonded to a carbon and a carbon. An aldehyde, this,
So it would be a ketone.
yes, this carbon would have to be bonded to a hydrogen, so it's not an aldehyde. To be a carboxylic acid, you need an OH group attached over here. So it's actually this, it's a carbon to a carbon and a carbon, so it's a ketone.
Go to the store.
Because that's carbon there. Yeah. whereas the aldehyde goes to hydrogen.
On Saturday, actually. What do you do?
No, that's okay.
And then on the other side, like on page
Yeah, the next
57,
slide, yeah.
slide 52, it'd be like
What?
amine,
Yeah,
because the amide
Yep.
has an oxygen and this one doesn't.
correct, correct.
No, it's a phone call.
I like. But.
Because you have a key like this.
The trees.
Off and everything you're in with.
But
Yeah. Well. You don't just have what you said.
My current powder.
Would the last one be aromatic?
Aromatic, yeah.
5 liters.
But you also have, there's two parts to it. So the one piece is an aromatic.
Two?
What are you doing now?
No, I think 6 ounces.
It's a double.
It's all 7.3, she was so off.
Okay.
They have to like specify.
So we'll show both parts if there's two parts to it.
Okay.
So what did you guys get for this one? Amine,
Next one's amine,
amine.
and then amide.
Okay, so then, let's take a look at this one. We've got an N attached to a carbon.
Attached to another carbon to an oxygen.
Yeah, so there's a
Amide.
carbon in the middle. So there's actually two parts. There's this guy and this guy are two separate things.
So would it be like amine?
Yeah, so this is the amine. So if this carbon was, if this was a carbon with a double bonded O, then it would be an amide. But because it's a carbon to a carbon, it separates them. So it's just an amine. And then this guy has our carbon with a double bonded O and an OH group. So that's, like Julie said, carboxylic acid. This also has two groups, so I think Annika was pointing out that this with the rings is aromatic. What about this group over here? Oxygen to a carbon to a carbon.
Ketone?
Ether?
Ketone. How do you, why do you say ketone, Blue Jay?
Oh, there's 3 C's.
Or
sorry, carbons.
This C is to a C and this is a C, yeah.
Yeah.
So it's all C's, so ketone. Okay,
Ibuprofen.
yeah, so that's what gives, that's the chemical formula for ibuprofen that you take for headaches.
I found out that you have to take ibuprofen with food.
Oh, okay. So harder on your stomach?
Yeah.
Yeah, it hurts.
Is it? Okay.
You like wake up in the morning and just take an Advil.
Is your pen supposed to look like an ether?
Yeah.
So Halloween special. Okay, so take a look at those ones. There's more than one group. Try to figure out what groups they are. And then we'll go through them.
No,
There
it's just
be
a regular.
more than
black
2
pen.
groups?
There can be, but there isn't in these examples. But yes, in some of the practice you do, there will be more than 2 groups.
She got it in. Sorry.
And then for the ibuprofen, there would be like 3 groups.
No, come, look.
Apparently not.
There can be more, but there isn't. It looks like there's lots going on, but you really are just worried about anything that's not carbon and hydrogen and the ring.
So we don't worry about the rings.
Well, the ring has double bonds, so that's the only reason it matters. Okay, but if it's single bonds, it wouldn't.
Aromatic?
Yeah.
And then carbon?
Yeah. Carboxylic acid, yes, that crazy word.
But your hair kind of looks blonde in this.
Yeah.
Like parts of it.
My hair's going white.
It's all the stress.
And thyroid.
ibuprofen, and amphetamine.
More contrast, yeah, gosh. This one.
The only time I texted the kid was when asked me about coffee.
You got, what do you,
I don't know, bro.
got aromatic here?
Yeah.
Perfect.
That's it. That I haven't seen.
And this O, double bonded O to OH group carboxylic acid.
I don't like.
Last one, last.
Aromatic.
All I got so far.
And then this N group. So which N group is it? Is there a double bonded O attached to it or nothing?
Nothing.
So nothing means it's
Amide.
amine with an N, yeah.
They sound really similar.
They do, I know, it's like, it's really tricky. So if you guys go to your package of papers that I gave you, there is some practice for identifying functional groups. There's a chemistry of smell lab, that will be tomorrow, so you don't need to worry about do the practice, and then there is a hand-in. If you get to the hand-in today, that's good, if not, you'll probably have some time in the lab as well. So that's today's stuff.
I'm just looking for the hand in.
It's, I think, a yellow sheet, and it should be in your package as well. We waited all that